All right, so this is the review sheet for exam 2. So problem 1 is to differentiate some functions. If y is x squared times the square root of 1 minus x squared, which is x squared times 1 minus x squared to the 1/2, dy dx by the product rule and the chain rule, it's 2x times 1 minus x squared to the 1/2 plus x squared times the derivative of this, which is 1/2, 1 minus x squared to the minus 1/2 times minus 2x. So this is 2x times the square root of 1 minus x squared. And the 2's cancel. I have minus x cubed, x squared times x, over the square root of 1 minus x squared. And if I put everything over a common denominator of 1 minus x squared, I get 2x minus 2x cubed minus x cubed minus 3x cubed. So if I didn't make any mistakes, that's the answer. If y is sine 3x plus 2 cosine x, dy dx is 3 cosine 3x minus 2 sine x. If y is e to the x plus 3 to the x, again, 3 to the x is like e to the constant times log 3 times x. So dy dx is e to the x plus log 3 times e to the log 3 times x, or e to the x plus, this is just 3 to the x times log 3. D, we use the quotient rule. Y is tangent x over x cubed minus 1. So dy dx, we have x cubed minus 1 squared in the denominator. The derivative of the tangent is secant squared x times the denominator minus the derivative of the denominator times the numerator. That's the answer. For 1e, y is the arctangent of x squared. So by the chain rule, we know the derivative of the arctangent of x is 1 over 1 plus x squared. So this is 1 over x squared squared times the derivative of x squared, which is 2x. So that's 2x over 1 plus x to the 4th. And finally, f, if y is this 5x plus 6 over 4x plus 5, again, by the quotient rule, you get 4x plus 5 squared in the denominator. The derivative of the numerator, which is 4 times the denominator, minus the numerator times the derivative of the denominator. 5, 4, that's 20x minus 20x, they cancel. 25 minus 24 is 1 over 4x plus 5 squared. Problem 2, if we have the curve given by x squared plus xy plus y cubed equals 11, implicit differentiation, if you differentiate with respect to x, the derivative of x squared with respect to x is 2x. The derivative of xy with respect to x is the derivative of x, which is 1 times y, plus x times dy dx, which is what we're trying to figure out. Derivative of 3y cubed with respect to x is 3y squared dy dx equals the derivative of the constant function 11, which is 0. So this says that 2x plus y plus x plus 3y squared dy dx equals 0. So dy dx is minus this over this. That's implicit differentiation. Now, on this curve, x squared plus xy plus y cubed equals 11. If you look at the point 1, 2, that is when x equals 1 and y equals 2, if you plug those numbers into the left-hand side, you get 1 squared plus 1 times 2 plus 2 cubed is 1 plus 2 is 3 plus 8 is 11. So this point lies on the curve. So whatever this curve looks like, some point on the curve is 1, 2, and there's a tangent to the curve at that point. And what is the equation of the tangent line? Well, the slope of the tangent line is dy dx evaluated at the point 1, 2. So this is dy dx, call the slope m. So m is minus 2 times 1 plus 2 over 1 plus 3 times 2 squared. That's minus 4. 3 times 4 is 12 plus 1, minus 4 over 13. That's the slope of the tangent line. So by the point slope formula, the tangent line is y equals minus 4 over 13, x minus 1 plus 2, which is minus 4 over 13x plus 4 over 13 plus 2, which is 30 over 13. So that is the equation of the tangent line. Problem 4, we have a function y equals 1 plus x cubed times 1 plus 2x squared times 1 plus 3x to the 5th. And we want to use logarithmic differentiation to find dy dx. So the log of y, you just take the log of all this, you get 3 times the log of 1 plus x plus 2 times the log of 1 plus 2x plus 5 times the log of 1 plus 3x. If you differentiate log y with respect to y, you get 1 over y dy dx. On the other hand, this is log y, and when you differentiate this, you get 3 over 1 plus x plus 2 over the derivative of this is 1 plus 2x times 2. The derivative of this is 1 over 1 plus 3x times 3. So dy dx is y times 3 over 1 plus x plus 4 over 1 plus 2x plus 15 over 1 plus 3x. That's what it is. Problem 5 is a related rate problem. We have a cube, and let's say the side of the cube is x. And we're told that the edges of the cube are expanding at a rate of 4 centimeters per second. So the rate of change of x with respect to t is 4 centimeters per second. What is the volume of a cube? Well, as a function of x, the volume is x cubed. Of course, the volume is a function of t because x is a function of t. So dv dt is equal to the derivative with respect to t of x cubed This is the derivative of x cubed with respect to x dx dt. The derivative of x cubed with respect to x is 3x squared, and we're told dx dt is 4. So this is 12x squared. That's the rate of change of the volume. So at x equal to 12 centimeters, when the edge is 12 centimeters, the rate of change of the volume is 12 times 12 squared, which is whatever 12 times 12 squared is. (1,728 cubic centimeters per second). Now, on the cube, each side has an area of x squared, and there's 6 sides: front, back, top, bottom, right, left. So the surface area of x is 6 times x squared. And if we want to know how fast the surface area is changing, that's the derivative of this with respect to x, which is 12x dx dt. Again, dx dt is 4, so this is 4 times 12. This is 48x. And when x is equal to 12, you get 48 times 12. Which is 576 square centimeters per second. Let's see. Next comes problem 6. We want to find the absolute extrema of the function g of t equal to t cubed minus 3t squared plus 5. So the absolute extrema occur on the endpoints of the interval. We're only interested in the interval from -2 to 2, and the relative maxima and minima. They occur where the derivative is 0. The derivative is 3t squared minus 6t, which is 3t times t minus 2. And that equals 0 at t equals 0 and t equals 2. So we make a little table, t and g of t. We have to look at the relative maxima and minima, and also the endpoints. Well, one of the endpoints happens to be 2. So we only have to calculate this function at 3 points. When t is 0, this is 5. When t of 2, this is 8 plus 5 is 13 minus 12, so that's 1. When t is negative 2, this is minus 8 minus 12 minus 20 plus 15 is minus 15. So this is the absolute max, and this is the absolute minimum of this function on the interval. You look at the endpoints and you look and see where is the derivative 0. The derivative is 0 at 0 and at 2. And you evaluate the function at those relative maxima and minima and the endpoints, and you see what's the largest and the smallest value. Problem 7, we're looking at the function f of x equals x squared over x squared minus 9. The derivative is you have x squared minus 9 squared. The derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. I have 2x cubed minus 2x cubed. What's left is minus 18x over x squared minus 9 squared. So what are the critical numbers? The derivative, the critical numbers where the derivative is 0 or doesn't exist. The derivative is 0 at x equals 0, and it doesn't exist when x is plus or minus 3. So, and this function is, so where is this function increasing or decreasing? Well, the denominator is always positive because it's a square. So f of x is increasing where minus 18x is positive. So that means x is negative. It means minus infinity to 3 to minus 3 and minus 3 to 0. And f of x is decreasing where this is negative, so x is positive and not equal to 3. So 0 to 3 and the open interval from 3 to infinity. And the relative extrema, well, there's only one at x equals 0. In fact, if you wanted to graph this function is 0 at 0, between minus 3 and plus 3. This is negative and this is positive. So this function is negative and it's going to infinity like that. And when x is bigger than 3, this is positive. It's bigger than 1, and it's actually approaching 1 asymptotically. You go to plus or minus infinity. So that you have a relative maximum at x equals 0, and that is the only relative extrema. Functions increasing, increasing and decreasing, decreasing. For problem 8, we have the function f of x equals 4 over x squared plus 1. So this is always positive. If you take the derivative, the derivative of the numerator, which is 0, minus the numerator times the derivative of the denominator, which is 2x. So it's minus 8x over x squared plus 1 squared. And this is 0 only at x equals 0. And this derivative is negative for x positive and positive for x negative. And when x is equal to 0, it's equal to 4. So this function is increasing till you get to 4, and then it's decreasing. And at x equals 0, you have a relative max at x equals 0. Now, what are the points of inflection? So you have to look at the second derivative. The second derivative is minus, see, let's differentiate this whole thing. You have the square of x squared plus 1, so that's x squared. You have the square of x squared plus 1 squared, which is x squared plus 1 to the 4th. The derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, which is 2 times x squared plus 1 times 2x. So this is minus I can factor out an x squared plus 1. And what I get is 8 times x squared plus 1 minus 8 times 2 times 2 is 32 x squared, period. You factor out x squared plus 1, you get 32 x squared. Over the denominator. So this cancels one of these, x squared plus 1 cubed. And what I have is 8x squared minus 32x squared, which is minus 24. I get 24x squared minus 8. Or if you like, 8 times 3x squared minus 1 over x squared plus 1 cubed. And that's equal to 0 when x is plus or minus, x squared is plus or minus a third, so plus or minus 1 over root 3. So we have inflection points. So when x squared is, say this is 1 over root 3 minus 1 over root 3. So when x is in between, this is negative. So this curve is convex down. And when x is bigger than this or less than minus that, curve is convex up. So those are the inflection points. So you have inflection points where the second derivative is 0, x is equal to plus or minus 1 over root 3. And if you put in 1 over root 3 or minus 1 over root 3, you get the same thing. You're squaring it. You get a ninth. Sorry, you get a third. So you get 4 over a third plus 1, which is 4 over 4 thirds, which is 3. So you have inflection points at plus or minus 1 over root 3, comma 3. Problem 9 is to find two limits. We have a limit of 4x minus 1 over the square root of x squared plus x as x goes to infinity. Let's see, we could say this is the limit as x goes to infinity of 4x minus 1 over the square root of x squared times 1 plus 1 over x. So this is the limit as x goes to infinity of 4x minus 1 over x. I can take the square root of x squared over the square root of 1 plus 1 over x. Or if you like, this is the limit as x goes to infinity. Divide this by x, I get 4 minus 1 over x over the square root of 1 plus 1 over x. And as x goes to infinity, the 1 over x goes to 0, and we get 4 over 1, or 4. And that's the limit. If we take the limit as x goes to infinity of 5x cubed minus 10x plus 3 over 2x cubed plus x squared minus 9x minus 1, when you have a rational function that is a quotient of polynomials and they're of the same degree, as x goes to infinity, the limit is just the ratio of their leading terms. So that would be 5 over 2. That's the answer. Problem 7 is a maximization problem. Sorry, problem 10. We take the semicircle of radius 10. This is 10, 0, minus 10, 10. And we're going to inscribe a rectangle in the semicircle as big as possible. So if this is x, you go up as far as you can, you go over to get a rectangle. This will be minus x. What are the coordinates of this point? So the equation of a semicircle was x squared plus y squared equals 10 squared over 100. So y is 100 minus x squared, square root. So if x is the corner of the rectangle on the x-axis on the positive side, this point will have coordinates x, comma, square root of 100 minus x squared. So the area of the rectangle is a function of x. The area of a rectangle is the base times the height. From minus x to x, the base is 2x, and the height is the square root of 100 minus x squared. And we want to find the x that makes this area as large as possible. So to maximize a function, we differentiate. We get 2 times the square root of 100 minus x squared, plus 2x times the derivative of this, which is 100 minus x squared to the minus 1/2, a half times this to the minus a half, times the derivative of 100 minus x squared, which is minus 2x. So this is 2 times the square root of 100 minus x squared. This 2 and this 2 cancel. So I get minus 2x times x minus 2x squared over this square root of 100 minus x squared. Or if I want to put this over a common denominator, and I can factor out the 2, I get 100 minus x squared minus x squared. And we want that to be 0, which means the numerator should be 0. So x squared equals 50, x equals 2 root 5. That's the square root of 50. And when x equals 2 root 5, y is the square root of 100 minus x squared. That's the square root of 100. If you square this, square root of 5 times square root of 5 is 5 times 4 minus 20. So this is square root of 80, it looks like. 80 is 5 times 16. This is 4 root 5. So the dimensions of the largest rectangle that can be inscribed in the circle, this is root 5, 0, root 5, 4 root 5, minus root 5, 0, minus root 5, 4 root 5. This dimension is 2 root 5 from here to here. This dimension is 2 root 5. So when x is 2 root 5, and you square it, you get 20. The square root of 84 root 5. Those are the dimensions. In fact, it's actually a square. Because from minus 2 root 5 to plus 2 root 5 is 4 root 5, and we're going up that amount in height. Right. Let me just go through this again, because these are hard problems to do when you're learning how to do them for the first time. We take the semicircle of radius 10 that has the equation x squared plus y squared equals 10 squared or 100. So y is the square root of 100 minus x squared. That's the equation of the semicircle. And if you take a point x and you go up as high as you can until you hit the circle, this height is a square root of 100 minus x squared. So if you want to pick the largest rectangle inscribed in the circle, pick a point x for the right-hand endpoint. Go up as far as you can, go over as far as you can. You're going from minus x to x, and from 0 to square root of 100 minus x squared. So that area is the base 2x times the height, and you want to maximize that. So you're differentiating. The derivative is 2 times the square root plus 2x times the square root, which is a half, this to the minus 1/2 times minus 2x. So it's 2 times the square root. See, the 2's cancel. I get minus 2x squared over the square root. So that's 100 minus 2x squared over this times 2. And that's 0 when x squared is 50, or x is 5 root 2. Oops, maybe that was my mistake. So that's silly. So this is 0 when 100 minus 2x squared, so 2x squared is 100, x squared is 50. Square root of 50 is 5 root 2. And when x is 5 root 2, y when x is 5 root 2 and x squared is 50, y is the square root of 100 minus x squared, which is the square root of 100 minus 50, which is the square root of 50, which is also 5 root 2. So x is 5 root 2, and this height is 5 root 2, and this is minus 5 root 2, and then this is 5 root 2. So, and this maximum area, if we're interested, is the base times the height. From minus 5 root 2 to 5 root 2 is 10 root 2 times the height, which is 5 root 2. So that's 5 times 10 is 50 times 2. So we get 100 is the maximum area of this inscribed rectangle. Okay. Problem 11 is a nice kind of problem in geometry. We have the parabola 3 minus x squared. So minus x squared, so it's opening down. You get, when x is equal to 0, y is 3. When x is root 3, which is about 1.7, y is 0. Parabola looks something like that. And we want to find the points on the graph which are closest to the point 0, 1. This is 0, 1. This is 0, 3. So for any point on the parabola, we want to find this distance and minimize it. So this is a point on the parabola x, y, but y is 3 minus x squared. So the distance formula says the distance from this point to this point is the square root of the differences of the coordinates squared, x minus 0 squared plus 3 minus x squared minus 1 squared, which is the square root of x squared plus 2 minus x squared squared, which is the square root of x squared plus 4 minus 4x squared plus x to the 4th, which is the square root of x to the fourth minus 3x squared plus 4. That's the distance. And I'm taking a square root. You can minimize the distance by also minimizing the square of the distance. And the square of the distance just gets rid of the square root. So let's say d of x is the square of the distance from a point on the parabola to 0, 1. And that's given by x to the fourth minus 3x squared plus 4. So if that's the distance, d prime of x is 4x cubed minus 6x. That's equal to, let's see, factor out of 4x times x squared minus 3/2. And that's equal to 0 when x is equal to either 0 or plus or minus 3/2. Now, when x equals 0, you have this distance from here to here. That's actually going to turn out to be a relative maximum. If we want to double check, if we take the second derivative, that's going to be equal to 12x squared minus 6. That's 12 times x squared minus 1/2. When x is 0, you get minus 6, which is negative, which means a relative maximum. When you evaluate this, the second derivative at plus or minus root 3/2, you get 12 times 3/2 minus 6 is 18 minus 6 is 12, which is positive. So you have relative minima at x equal plus or minus root 3/2. And when x is plus or minus root 3/2, y, this is 3 minus 3/2. Y equals 3/2. So these are the 2 points on the curve closest to 0, 1. X equal 3/2 and 3 minus 9/4 is 3/4. Plus or minus, sorry. Plus or minus 3/2. Plus or minus, let me do this correctly. So when x is plus or minus the square root of 3 over 2, y, which is 3 minus x squared, is y minus 3/2, is 3 minus 3/2, which is 3/2. So these 2 points on the curve have coordinates plus or minus root 3/2, comma 3/2. That's the result. And then the last problem is find positive x and y such that the sum is 12 and the product is a maximum. So if x plus y is 12, that means for any x, y is 12 minus x. So xy is x times 12 minus x. That's 12x minus x squared. This is some function of x which we want to maximize. So f prime of x is 12 minus 2x, which is 0 when x equals 6. The second derivative is minus 2, which is negative. So x equals 6 is a maximum. And when x is equal to 6, y is 12 minus x, or 12 minus 6, or 6. So the maximum product for x plus y equal 12 is x equal y equals 6, and the product xy is 6 squared, or 36. That's the best you can do. And that completes the review sheet.